In section 8.4, we learned how to factor polynomials that were in the form of x squared plus bx, where we factored out an x and whatever number, greatest common factor of the numbers in front of the x. So this week we're going to start factoring polynomials that have a constant term. So we can't just pull out an x because there's no x in the constant term. So remember that factoring is the same thing as unmultiplying. Okay, so it's the reverse of the distributive property. So first thing I want to do is multiply these two linear terms together and see what we get. And I will use the FOIL method. So f is the first, outer would be q times x. The inner would be p times x. And then the last are p times q. Remember that p and q are going to be numbers where x is the variable in this case. There is a common term in the middle two terms, and that is x. So I'm going to factor out the q. I'm going to factor out the x. So qx divided by x is q, and px divided by x is p. And what you need to look at is you need to look at the form that I just wrote and compare it to the top form. So the top form is x squared plus bx plus c. And our goal today, over the next 2 days actually, is to take things that are in this form and to turn them into two linear factors in this form. So what we're going to want to do is we're going to want to find two numbers, p and q, that multiply to the last number that add to the middle number. So that's the key point for factoring this group of problems, is finding two numbers that multiply to the last number that add to the middle number. I'm going to show you some patterns here. X squared plus bx plus c. I need two numbers that multiply to a positive, that add to a positive. If they multiply to a positive, they have to have the same sign, and both of those are positive. So in this case, they'll have an x plus p times an x plus q. Similarly, this pattern, x squared minus bx plus c, two numbers that multiply to a positive have to have the same sign, but they have to add to a negative, therefore both signs have to be negative. Then I can have x squared plus bx minus c. The two numbers have to have opposite signs, and then the one with the largest magnitude has to be positive. So I'd have x plus p times x minus q, where the absolute value of p is greater than the absolute value of q. And the last case is x squared minus bx minus c. They multiply to a negative number, and then the biggest number, so that means they're opposite signs, and the biggest number is negative because when I add them I end up with a negative number. So I'm going to write this as x plus p, I'm going to write x minus p times x plus q. And in this case, again, the absolute value of p has to be greater than the absolute value of q. When I write them out in factored form, I always make my p term the one with the biggest absolute value, and the one with the Q term, the one with the smallest absolute value. That way I use the same pattern every single time. So I'm going to erase the board, and I'm going to work through guided practices 1, 2, and 3 on page 595, and then guided practices 4 through 7 on page 526. So to show you how I set up these problems, I usually make an X, then I put a times sign and a plus sign. This is the way I think about it. I need two numbers that multiply to the number 2, that add to the number 3. Okay? And there's only one way to get 2 by multiplication, and that is multiplying 2 times 1. What I'm going to do is now take these two numbers and put them into my parentheses. So I'm going to put a 2 here and a 1 here. And again, I repeat that for all of these. So now is where it really comes apparent that you need to know your multiplication tables, and you need to know all the different ways to get these integers by multiplication. So I need two numbers that multiply to 10, that add to 7. Those two numbers in this case would be a 5 and 2. The only options I had here were 5 and 2 and 1 and 10, but if I had a 1 and 10, it would add to 11. So the answer here would be x plus 5 times x plus 2. Example 3, t squared plus 9t plus 14. Two numbers that multiply to 14, that add to 9. Again, I can have 1 and 14, which add to 15, or 2 and 7. So I'll put the 7 and the 2. And I end up, okay, previous example, this should have been an A. Watch the letters. In this example, I'm going to have a t plus 7 times t plus 2. The way you can check to see if your answers are correct is just FOIL them back out. X times x is x squared. Then I do the last term. 1 times 2 is 2. Then I add the middle terms. 2x plus 1x is 3x. A times a is a squared. 5 times 2 is 10. 5a plus 2a is 7a. T times t is t squared. 7 times 2 is 14. 7t plus 2t is 9t. So these are all positives. The last examples have our opposite signs here. Okay, so we're going to use some of these other patterns. In this case, I need two numbers that multiply to a positive 3 that add to a negative 4. It's a positive, so they have to have the same sign, and the sign's going to be negative. Only way to get 3 is with 1 and 3. So I just put those numbers in. And let's check. Negative 3 times negative 1 is positive 3. And negative 3 minus 1 is negative 4. So my answer is going to be x minus 3 times x minus 1. Next number, next group, t squared minus 8t plus 12. I need two numbers that multiply to 12, that add to negative 8. Again, they have to have the same signs because this is positive and that sign's going to be negative. My options for 12 are 1 and 12, 2 and 6, and 3 and 4. So 1 plus 12 is 13. That doesn't work. 3 plus 4 is 7. That doesn't work. But 2 plus 6 is 8. So I have negative 6 and negative 2. X minus 6 times x minus 2. You do not need to write out all of the factors of the number, but if you get stuck, start listing the factors of the number and then start playing around with them to figure out which gives you the right combination. I call this factoring by inspection, which means you should be able to take one of these and immediately write down the number. okay, without having to write this X box. Okay, this X box is just a tool to get you used to doing these problems. And the only way to turn these into factoring by inspection is to do lots of these problems. So you're going to see over the next 2 days, the homework assignment in class is probably going to have about 30 of these inspection type problems or solving these inspection type problems per worksheet in class. I expect you to be able to do one of these and solving them in less than a minute. So that's my expectations for this type of problem. So you need to practice to get used to meeting that expectation. Next example, two numbers that multiply to negative 20 that add to, remember there's a 1 here, a positive 1. Okay. They multiply to a negative, so they have to have opposite signs, and the biggest one has to have a positive sign. Okay, the biggest one has to have a positive sign here. So I'm immediately going to put that down, the plus and the minus. And my factors of 20 are 1 and 20. So in this case, the biggest one minus the smallest one, 20 minus 1 is 19, doesn't work. 10 and 2. 10 minus 2 is 8. It doesn't work. And then I have 5 and 4. 5 minus 4 is 1. That works. So positive 5 minus 4. Now write down the answer. I have m plus 5 times m minus 4. And again, on number 5, I made those x's. I'm going to make those t's. So they match up here. And the last guided practice before we start the last discussion for this section is w squared plus 6w minus 16. So I need two numbers that multiply to a negative 16, that add to a positive 6. They multiply to a negative, so they have to have opposite signs. The biggest number in magnitude has a plus. Factors of 16, so I'm going to take big one minus the small one, would be 1 and 16, 2 and 8, and 4 and 4. So 16 minus 1 is 15. That doesn't work. 8 minus 2 is 6, and that does work. 8 and 2. So my final answer would be w plus 8 times w minus 2. So again, these should become inspection type problems for you, just like your multiplication tables were in elementary school. Next thing we're going to talk about is once we factor these things, we need to be able to solve equations. So for example, if I had this equal to 0, all of these equal to 0, we could solve them. And I'm going to just use the same examples I had before. Another thing is I can be asked to find the zeros of an equation. Okay, an equation, remember, has the equal sign. Or I can be asked to find the roots or the solutions. All of these mean the same thing. And if it's anything in this form, you want to get every number except for the 0 onto one side of the equation with a 0 on the right-hand side, and then you just go about and factor. Okay? And then once I factor, I have two numbers that equal 0. So we set each of the factors equal to 0 and solve individually. And here is where no work is required. If it just has an x plus a number equals 0, my one step would be to subtract this number. X plus 2 equals 0, so x is equal to negative 2. Same thing here. X plus 1 is 0, so x would be negative 1. Once you get to this step, I expect you to be able to do this work in your head and write down your answers are x equals negative 2 and negative 1. Same thing here. These two factors equal 0. So I expect you to immediately be able to write x equals, subtract the 5, subtract the 2. A is equal to -5 and -2. Again, if these were set equal to 0, I would get t is equal to -7, or t is equal to -2. And if you notice, if I put a -2 back in for t, I get -2 plus 2 is 0. 0 times 5 is in fact 0. Or if I put a -7 is, -7 plus 7 is 0. 7 times -5, 0 times -5 is in fact 0. Number 4, solving it. Move the -3 over by adding it, so I get x is equal to 3. Add the 1 to both sides, or 1. Example 5. Add the 6 to both sides, so I get t is equal to 6. Add the 2 to both sides, or t is equal to 2. Number 6. If this was equal to 0, I would subtract 5, so I get m is equal to -5. Or I get m is equal to 4. And the last one, if this was equal to 0, I would get w is equal to, subtract the 8, -8. Or w is equal to 2 by adding the 2. So I didn't do more factoring examples. I've done 7 of them, but I wanted to show you how do we solve once we've factored them. Make sure that if you are given an equation to start out with, that you solve the equation. So first thing you do is you get everything onto one side of the equation so you can factor it, and then you will solve the equation. So that's it for notes for section 8.5. For your practice worksheet, you are going to do homework problems number 4 and homework problem number 20 on page 528. So you're going to be doing homework problem 4 and homework problem 20 on page 528. If you were in class the day I assigned this video, you will be given a worksheet that has those 2 problems on it. If you were not in class, please turn your book to page 528 and do those 2 problems to turn in at the beginning of class.